Hi, well, welcome everyone. Hopefully you can hear me okay. I think you're all on mute, so if anyone needs to ask a question, you can just take yourself off mute and jump in. Don't be afraid to jump in, or you can pop up the little chat box there at the bottom of your screen. So my name's Jason Hawley. I'm the Managing Director of Finn Biogas here, and I'll be running this webinar today. What I might do is start by kind of sharing my screen, and then we can get into the presentation. Alrighty, so hopefully everyone can see that screen there. All right, so first of all, I just want to say thanks to everyone for coming today. I know that everyone's time is pretty valuable, and as I said, thank you for for letting me know. Yeah, thanks everyone for coming along again today. I know everyone's time's pretty valuable. In the modern day world, things seem to move quite quickly, and so I'm really appreciative that you're here and you're excited to learn a bit more about the biogas industry. So I guess before we start today, just with that in mind, I wanted to get a little quick poll, people's thoughts about what they wanted to get out of the webinar today. So what are your burning questions about biogas? How can we help? What things do you need to know? You know, if you just have a few minutes to think about that while I start talking and rambling, there's a little chat box at the bottom if you want to pop that up and put any questions, any comments, anything you want to get out of today's webinar in there, then I'll try and get to them as best we can. So, all right, here we go. So as I said, my name's Jason Hawley. I'm the Managing Director of Finn Biogas, and we're a company based in Brisbane that designs and builds biogas plants. So my background is engineering. I'm a mechanical engineer, a chartered professional engineer, a registered professional engineer in Queensland. And my experience in the biogas industry spans around 8 years, and I've worked on projects across 9 or 10 countries, I think now. So as I said, all the stuff that we do is in the biogas industry, and I've worked across a whole range of different sectors: red meat, white meat, FOGO, food waste, intensive agricultures, piggeries, dairies, chicken farming, municipal sewage treatment, landfill, and pulp and paper. So Finn Biogas is based in Brisbane. We've been around since the start of 2016. And like I said, we design and build biogas plants. So one thing that I'm really proud of running this business is that we have 0 reportable safety incidents for the last 5 years. And that's something that's really important for any kind of company working in the industrial sector. Our focus is building biogas plants and bringing that within reach for clients. We really try and live by our motto of making waste work. So our focus is on figuring out from an engineering point of view how we can take projects and make them work. So instead of rambling too much, I thought what I'd do is share a little bit of an intro video about Finn Biogas, and hopefully that shows you a bit more about who we are. So here we go. All right, so hopefully that was a interesting little video for you guys to show you a little bit more about who we are and what we do. I guess just to wrap that all together, so like I said, we design and build biogas plants, and we do everything from the very start of concept design and initiation all the way through detailed design, construction, and handover of projects. All right, enough about Finn Biogas. I'm sure you're not here just to hear me talk about ourselves. So what I wanted to do is kind of get into some of the basics of biogas and give everyone a little bit of a first cut at understanding what biogas is, how it works, and then we'll chat a bit more about how that can work for the dairy industry in Australia. So this might be basic for some of you, it might be a rehash, it might be completely new for you. So for those that it's completely new for, I thought I'd start at the very beginning with understanding what biogas is. So biogas is a fuel that's predominantly composed of methane, generally also methane and carbon dioxide, and it's produced from the fermentation of organic material. What we like to say around here is it's a better way to do things. So you'll hear the term biogas plants, and the term anaerobic digestion, and they're kind of used interchangeably a lot of the time. So anaerobic digestion, biogas production, it's the same thing. So if we go to understanding what biogas is and how it's produced, we start at the start of the circle. I understand this drawing is not exactly a circle, but let's assume that it is. So anaerobic means the absence of air, and digestion is the breakdown of biodegradable material. So we have over here on the left some organic waste. So whether that's the likes of manure from animal production, it could be energy crops, it could be leftover food waste, or it could be sewage from sewage treatment plants. So that organic material goes into a biogas system, an anaerobic digester, where microbes take that organic material and consume the organics and produce biogas, which, as I said, is composed primarily of methane. We take that gas and we either produce electricity, or we can do a number of different things with that in terms of fueling vehicles or offsetting natural gas use. And then a part of the process during the biogas production, all the nutrients that went into the system also come out of the system. So we're able to capture that nutrient value and in turn circle it back around to agricultural land as a fertilizer product or a soil conditioner. So biogas plants or AD plants, what they do, they treat waste, organic waste, they make energy, and they create a nutrient-rich product. AD plants are not new. They're used all over the world. The process itself and the microbes that exist that produce biogas have existed for as long as time itself. But they can be innovative and they can be better understood. And there's lots of examples of them across the world. So like I said, we produce energy in the form of biogas. We can use that for production of electricity, for industrial heat, for production of biomethane or renewable natural gas to offset natural gas, and then also take that to vehicle fuel. The other part that comes out, the digestate, that's a nutrient-rich fertilizer, and we can take that to land. But there are other opportunities associated with biogas plants, such as generating income through gate fees, or taking intermediary products of the digestion to things like production of bioplastics, hydrogen, fiber recovery, and things like that. So lots of interesting things that you can do with biogas. and biogas plants themselves come in all different shapes and sizes. So you'll see here 2 examples of tank-based systems that we built. The one on the left is your typical European style wet digester with a flexible gas membrane roof on the top. And on the right is an industrial plant that we built overseas. And this also is a wet digester, just a slightly different configuration and sizing setup. You've got other options as well. Apologies for the clarity of the picture on the left. I didn't realize it was so poor, but this is a dry AD system. This is a plug flow type arrangement, it's called, where waste essentially goes in one end and is pushed along with these paddles which rotate and then pushed out the other end. And as you move that plug along, you produce biogas. This is probably what looks most familiar to most people within this webinar, I'd say. So lagoon-based systems, whether it's a lagoon which you line, or you've got the one on the right here, which is the type of system that comes as a bag. You essentially roll that out, pin it down, and that's more so used for waste that is a lot higher in moisture content, or a lot more liquidy. This is a plant we worked on in Central America, and this is kind of a hybrid lagoon complete mix system. And then again, not incredibly relevant for today's webinar, but you've got more industrial type systems, such as these. These are called UASBs, or internal circulation reactors, and they're more for industrial food and beverage production. So I guess if we go back a step, the point is there's lots of different types of biogas plants. They come in lots of different configurations, shapes and sizes, and they're all kind of useful for different things. The point is that you need to find the right mix between what you're trying to achieve and the design of your plant. So what I want to get into now is understanding a little bit about how biogas plants, or how AD, can help the dairy industry in Australia. So I think there's 3 kind of key things to start with, and these are the really important takeaways, if you will, I guess, from today. So biogas plants, from our point of view, can contribute to the dairy industry in 3 ways. The number 1 being economics, number 2 being environmental, and the 3rd being compliance. I wrote there compliance and odour. So let's start with number 1. I think it's really important to understand that with any kind of biogas project, there's site-specific economics, and understanding these economics can really allow you to exploit the opportunities of that plant. So as I said, we can use a biogas plant to generate electricity on site, and that allows you to create a form of energy independence, and also hedge your bets a little bit against rising prices of energy. There's also some untapped revenue streams within your business, possibly, and AD will help you tap those revenue streams and diversify your income a little bit. So things like sale of energy, maybe the sale of nutrient, possibly the recovery and sale of carbon dioxide as an industrial gas. And whether you view that as a revenue stream in your business, or simply as a cost offsetting opportunity, there's potentially money to be saved within your business there. I think the other really important thing that it does is it potentially creates a shift in the mindset, in that now within your business, you look at waste as a valuable asset, and you need to figure out how to exploit that. The second point, or the second way that I see AD can benefit the dairy industry in Australia, is really in the environmental sustainability and social responsibility sphere. So we talked about AD being used to create energy, but it can also primarily be used as a waste treatment or waste stabilization process to help kind of close the circle in the circular economy, if you will. We deal with a lot of clients who are primarily waste treatment clients. So whether that's sewage treatment, diversion from landfill, solid waste, these kinds of sectors. And they do biogas or they build a biogas plant as a portion of their treatment train, not primarily to produce energy, but to primarily treat the waste. And then they capture energy. It's a great side benefit for them. They can capture and reuse nutrient, and that's also a great benefit for them. But when we look at the way the world is kind of moving these days, I think it's very important to be environmentally aware. I think if you're in the agricultural space, if you're in farming, you're obviously very connected to the land and to the cycles, how these things work. And so it's not new to you. One of the key things that you can do with a biogas plant is capture and reuse nutrient. Now, we've seen in a lot of places in the world, or some places in the world, where particularly the dairy industry has caused problems with nutrient runoff, eutrophication of waterways, and these sorts of things. And so if you're capturing and treating and stabilizing your waste correctly, you have a lower chance of these problems occurring later. And then the big one, if anyone's seen the news recently, Australia's starting to move towards net zero carbon emission targets. And so biogas plants, obviously, by capturing gas, combusting that gas and making energy, you're reducing greenhouse gas emissions and reducing your carbon footprint. And obviously those emissions would otherwise just go up into the atmosphere. I can see a really interesting parallel between the dairy industry and some of the work we do in particularly the red meat industry, where there's a push more and more for carbon neutral meat. And so I'm not sure if that's something that is impacting the dairy industry or will come into the dairy industry, but it's an interesting thing on the horizon to consider. The third real big opportunity I see for the dairy sector is that a biogas plant helps with increasing your compliance. So obviously, if you're housing cattle and you're creating and capturing effluent from those cattle, you need to treat that effluent. So you need to do something anyway. And I think why not at least investigate putting that waste to work, making some energy, and reducing your emissions. The other real benefit we see, and I see a lot of parallels between the dairy industry and the work we do in the piggery industry, and that lots of projects are triggered in this space at the development application stage. So it's best to really be on the front foot when you're looking to expand or change or reconfigure your operations. The question is always asked, okay, what are you doing about treating your effluent correctly? And if you can confidently say, we're capturing that, we're capturing the odour, we're producing biogas instead of odour, you're going to have a better time with your development applications, and you're probably going to have nicer neighbours. So obviously in the news recently, there's been a few examples of dairy farm-based biogas plants in Australia. I don't know of too many of them, to be honest with you. I think it's an interesting developing market in Australia. But I've seen there's a biogas plant planned for Nowra, which I think is 18 farms that are all conjoining. They're all dairy farms. Looks like quite an interesting project. And I believe Moxie Farms also has a plug flow digester, just from what I've seen online. I think we might even have someone on the call from Moxie. So if you are, maybe you can shed some more light on that if you'd like to a bit later on. All right, so we've talked about what biogas is. We've talked about some of the benefits that you can expect from that. What next? What are the first steps you take? How do you go from watching a webinar, reading stuff online, to starting to investigate putting a biogas project in on your site? So what I think is really important is to get the basics down, get the basics nailed first. So start with the drivers of the project. Understanding the drivers of your project are the really key to success. So are you trying to make return on investment on this? Are you trying to just treat your waste and manage your waste properly? Are you trying to generate energy security, or are you trying to do something else? And understanding that will help shape and drive the way that you go with your project. I've written here that there's some secondary drivers around energy security, nutrient recovery, green credentials, etc. I think the other really important thing to do is decide up front on your appetite for complexity. There's a lot of talk about the aggregation of waste from different sources, bringing waste onto farm, understanding your market exposure, biosecurity, all these types of things. And I think it pays to sit down, understand within yourself or within your business what that appetite is for complexity before you move too far down one path or the other. Once you understand all of these things and you put them all together, that really starts to drive your project. So it starts to drive the things that I talked about earlier. So do you want to go with a tank-based system, a lagoon-based system, a high-rate system? What's your complexity? What's your risk allowance between the different parties? And ultimately, what's your outcomes? What's your cost? And what's your return on investment? So once you've done that, we would very strongly suggest the next thing you need to do is undertake some kind of feasibility study. So this is a study you can do on your own, or it's something that companies like Finn Biogas do. We can help you with that, absolutely. And in this stage, you need to kind of gather as much data as possible on your operations. You need to get together the right team internally within your business. And if you need to consult out, get some subcontractors in, get consultants in, get experts in, it's probably a good time to start looking at doing that in the feasibility stage. I'd also suggest during that time that you really engage with regulatory bodies and other stakeholders. And so you can kind of start to head off those conversations early before your project goes too far down the path. So during a typical kind of feasibility study, pre-feasibility study, front-end design, you really need to kind of start to flesh out, what are you going to do with the energy you produce? What are you going to do with the digestate? What's the best use of those? How can you get the maximum value out of those? Along with that, you want to understand what scale of plant makes sense for you, to not only to build, construct, but also to own and operate. What are the downstream benefits? What are the upstream benefits or consequences of putting a biogas plant into your process? And what are the project's risks and how do they change through the project lifecycle? So for now, I would start with that and I would understand what's for now and what's for later. There's a lot of really cool stuff you can do with AD, like I mentioned before, bioplastics, CO2 recovery, biomethane, hydrogen upgrading, etc. And you need to kind of understand where those technologies sit within the project life cycle, what makes sense for you from a complexity point of view. Once you've done that, you probably want to go out, assuming your results are positive and you've got a go, no-go case, you might want to go out and try and source some funding. Maybe you have your own source of funding, but I thought it'd be interesting to just drop in here a couple of things that exist at the moment. And these are for particularly projects in Victoria and New South Wales. In Victoria, there's the Energy Innovation Fund, which is grants from $2 million to $20 million and up to 50% of the cost of a project. And this is for energy projects which are renewable in nature, so hydrogen, biogas, energy storage. And it's funding to complete front-end engineering design, feasibility study, pilot scales, demonstration plants before a project's completely commercialized. Seems like a really great fund. I'd highly recommend getting amongst it, having a look at it, getting into the details of that. In New South Wales, there's the Waste Less Recycle More Fund from the EPA in New South Wales, and that's grants of $25,000 to $2 million. And that's probably more so for the FOGO market, so food organics, garden organics, curbside collection. But same thing, it's a clear indication from the government that these kinds of projects are interesting and are being funded. So I'd recommend getting out there, having a look around, trying to figure out what sources of funding are available or applicable. Once you've kind of secured your business case, your feasibility study, your funding, you probably want to decide on what your appetite is for, or which appetite you've got for, which model you've got an appetite for in terms of building a projects. And there's many options, like any projects, whether it's a biogas plant or something else. There's lots of different ways in which projects can be completed. So you can build a project with someone who provides a whole turnkey, EPCM, you can do a self-build model. And again, that comes back to understanding your project drivers. It's kind of at that stage, you want to also look at your permitting and your licensing, and you want to engage with a local partner who really can articulate and understand and is across things like Australian standards, development applications, planning approval. After you've obviously decided that, you go ahead, you design and build a project. Then you need to commission that project. So you plan out your commissioning work well. And again, I'd really recommend you work with someone who's very experienced in that area. Again, it's something that Finn Biogas that we do. Whether you choose to go down that path with us or with someone else, I would just really recommend you pick someone who is experienced and knows what they're doing, because commissioning and startup is quite critical to the success of a plant. It's critical in the sense that you're building that colony of bacteria who are going to maximize the amount of gas and energy that you produce. But it's also a potentially dangerous time in terms of crossing through explosive atmosphere limits and things like this. All right, so just a couple of tips. I'm sure if you've built any project before, you'll know that not just biogas or bioenergy projects, but all projects are inherently complex. Expect things to change, timelines to blow out, problems to come up, and that's totally normal. If you've not done this before, I can assure you 100% that that's totally normal, and there's always a solution. It may not be cheap, it may not be quick or easy, but there's always a solution. Get on board with the right team early. Get your team internally sorted out and get your consultants sorted out. Understand what the best communication, working style, and flexibility are. Again, projects are challenging, keep the faith, but there's a ton of great benefits to owning a biogas plant. All right, so that's all the presentation that I had formally structured. We've got a few minutes still for questions, so I thought I'd throw it open to the floor. And if anyone has any questions, you can put your hand up or you can drop a message into the chat box. And I can run through some of the questions that we've got sent in previously. All right, let me just see what's popping up. Cost. Okay, a question around costing. So costing is always a question that's a little bit tricky. How much does a biogas plant cost? Well, it's a little bit, how long is a piece of string? So there's going to be quite a number of factors which come into costing. Anything from, what your project drives are, if we go back to that, how much complexity, the way you structure your project, the scale of your project, all of those things. But expect anywhere in the very bottom end to spend $1 million and then upwards from there. We've been involved in projects where the bottom end is a few $100,000 and the top end is 60 million. I think it's probably the largest project we've worked on. So I know it's a key question, but it's also very tricky to answer. As a rule of thumb, I guess medium to large size family-owned farming operations would generally spend 2, 3, 4 million, something like that on capital cost. So another question I've got here is in terms of, let me see what's written down. So in terms of what information we'd need to complete a feasibility study. So this is a question that was sent in. So in order to complete a feasibility study, we'd need to know, the amount of waste or effluent that you have, the volumes either on a daily or a yearly basis. We'd kind of need to know what your project drivers are, and we can help flesh that out. And we'd need to understand what your site looks like, what your constraints are, and what you're really hoping to achieve. Would also obviously need to do a really good feasibility study. We'd need some data around cost of energy, and we'd probably like to take some samples and send them away for testing as well. Depends on the level of complexity. So that's a good question. Thanks for sending that one in. All right, so another question has come in. Am I able to run through some of the pros and cons of different AD technologies? So covered lagoons, plug flow, etc. Yeah, that's a really good question, actually. Thanks for that question. So, if I go back in the slides, a little bit to the different technologies, I can kind of run through them a bit more slowly this time and give you a bit of an upshot. So if we start with these kind of wet AD systems, so these are generally tank-based systems, and these are what's called a CSTR, complete stirred tank reactor, or a complete mix system. So in here, what happens is we have a tank and we put everything in and we mix it up continuously to produce the biogas. So the advantage of a system like this is that you can control the environment very well in comparison to a lagoon or another type of system. So that means you can kind of optimize the conditions for the bacteria to grow, which means you can maximize the amount of energy that you're recovering. Complete mix systems like this will handle waste, which is a lot more solid than just your standard effluent. So we use them for a lot of, I guess, sludges, a lot of things like chicken manure. They're used for cattle slurry that's not watered down too much. And so they're really good for that, for really controlled environments, maximizing your gas production. If you go to a system, we'll come back to plug flows, but if you go to a lagoon system, so whether it's a lagoon like this or a bag or a hybrid type system, these are really good for certain applications where the volume of effluent is quite large. You want a system that's a little bit less complex, easier to operate, a bit more cost effective, cost competitive. Particularly if you're on farm, you can probably manage construction of a lot of this yourself. And these systems work well with very low solids concentration. So things like piggery effluent, for example, where there's only a small amount of solids and a lot of water that kind of gets in the way, these work really well. I wouldn't advise putting a lot of solids into a lagoon. The reason being is that you kind of get solids settling to the bottom and you get solids floating, and that becomes a problem because you get stratification of the layers, you get a temperature profile, you start to kill bacteria because the anaerobic bacteria only lives within a certain temperature range. And then you potentially have problems with a crust forming, gas not escaping, not being able to mix a huge volume. It's really important for the bacteria to live in an environment which is, I guess, similar to humans in that we like the right temperature. We like to I guess, have a consistent dose of feed. And for the bacteria, it's no different. They want a temperature range and they want to be continually mixed so that they've got their food and that the bacteria can access that. So good for things like piggeries, good for dairies, not so good for food waste and things like this. When you look at a plug flow, there's, I guess, a few different configurations of plug flow digesters. You've got, I guess, these types here where you drop everything in one end and you push it along with paddles. You've also got the plug flows where just the inflow pushes everything through a serpentine. And you've got, I guess, what's not shown here is more garage systems. And so these type of plug flow reactors, they're good for things that are even much higher again in solids concentration. And so they're used typically for a lot of, I guess, municipal solid waste, things like FOGO, things with a lot of contamination. That's not going to, you don't want to get caught in pumps and mixers. They generally have a lower retention time, but again, they're heated and you mix them very slowly and push everything along. But they are generally more expensive to build. So they're used for municipal and industrial applications. Then you've got the group of high rate systems, let's say. So this is what's called UASBs or ICs, any number of different technologies where essentially coming into the bottom of these big tanks comes your effluent or your high strength liquid organic waste, high strength wastewater comes in. You form a blanket of sludge where the bacteria live. And as that water passes up through there, the organic material gets caught and digested and then goes out the top in a much more clean fashion. These are normally used for applications that are industrial food and beverage production, where there's, I guess, high solids or high suspended or dissolved solids, high dissolved solids in here, but not necessarily a lot of particulate matter. So you can pass effluent through these relatively quick, which makes them smaller, on a smaller footprint. But again, they're rather complex and can be challenging to operate. So hopefully that answers that question, a long-winded answer, hopefully. All right, next question in terms of average time frame for design concept to full install. Again, it's a good question. It depends really on the project complexity, but for a farm application, let's say for a dairy application, you're looking in the 12 to 18 month kind of window from initial concept, design, procurement, construction, and commissioning. And then larger industrial projects that we work on are generally 18 months, 2 years, something like that. Yeah. Okay. So a question about subsidies. Any rebates supporting biogas at the moment? So yeah, unfortunately, it's quite a tricky, I guess, question to answer. In that the easy answer is no. So there's some funding, like I showed you. There's also, I guess, some funding like ARENA, potentially fund different types of projects which are maybe a bit more innovative. But in terms of offtake tariffs or feed-in tariffs or things like this, unfortunately, at the moment, there's no real market mechanism as incentives like that. I think that there really should be. I think that in time, it looks like we'll move back to some form of a carbon tax, whatever you call it, but at the moment, it's quite challenging in that sense that projects need to stack up on their own. Yeah. Okay. So another question about revenues. What revenue streams make a project financially viable in Australia? Behind the meter usage, selling electricity into the wholesale market, gate fees, or third-party waste, etc. Again, really good question, and it's tricky to answer because it's always site specific, and it's always specific to the drivers of the project. So we work on some projects, for example, where the whole economics is based around providing gate fees. So the client owns this site. Someone comes and essentially pays a fee to dump their waste at the site, and that's how their economic model stacks up. And then we work on other projects where someone might be on a farm at the end of a transmission line. Maybe they're getting load shedded off that line. Maybe they're paying a premium for their energy. Maybe they're importing diesel. There's a whole range of factors. Maybe they're paying to dispose of waste, and that really sets up the economics in a different way, in a different condition than the previous example I gave. So it's challenging, and it's always site specific. Some are driven by gate fees. Some are driven by cost of waste disposal or waste treatment. Some are driven by selling energy. And there's no hard and fast rule necessarily, and there's not always a direct match. Biogas is really great for lots of things, but it's not the be all and end all. I'm not going to sit here and tell you that it's perfect for every condition. And unfortunately, that's why you need to do a feasibility study, a site assessment type of work to understand what works best for your site and what you're trying to achieve. And it might be biogas, or it might be a combination of biogas and solar and wind, or it might be something else. So if there's no other questions, I want to again say thanks to everyone for coming. It's been a really good chat. It's been really informative for me to understand, and hopefully I've added some value to everyone's day. We're always here. My details are here on the slide, you can see. If not, you can call our office. You can find us online. If there's anything you need a hand with, biogas related, even if you just want advice, you want to chat, we're here to help. Give us a bell. Hopefully it's been helpful, and thanks again everyone for coming. And I might stop it there. Thanks guys.